In this lesson, we will look at how to use some differentiation rules on some exponential and logarithmic functions and some simple trigonometric functions as well. First off, for the exponential function e to the x, the derivative is just e to the x. But if the exponent of e to the x is not just x, but some other function in x like e to the power of 2x or e to the power of x cubed plus x, then we need to use the chain rule for this. But using the chain rule, the formula becomes d dx of e to the power of f of x is equal to e to the f of x times whatever the derivative of f of x is. So if we use this as our first example, d dx of the derivative of e to the power of x will then be, using this formula, we just sort of copy e to the power of 2x and then multiply it by the derivative of 2x, which is 2, and then just rewrite it as 2e to the power of 2x. For this next one, if we get the derivative of e to the x cubed plus x, again, we copy the given function, e to the x cubed plus x, and then we multiply it by the derivative of the exponent x cubed plus x cubed plus x, which is 3x squared plus 1. And then just rewrite this as 3x squared plus 1 e to the power of x cubed plus x. Next one is the derivative of ln x, which is just 1 over x. But if we find the derivative of the ln, the natural log of some other function, say ln 3x plus 2 or ln 1 minus x cubed, then we need the chain rule for this. But we also have a formula handy for this, and that is d dx of ln f of x is just equal to 1 over f of x times whatever the derivative of f of x is. So if you take this example, first one, get the derivative of ln 3x plus 2 using this rule, it will just be 1 over 3x plus 2, then multiply it by the derivative of 3x plus 2, which is 3, and then just simplify it as 3 over 3x plus 2. This next one will be 1 over 1 minus x cubed times the derivative of 1 minus x cubed is negative 3x squared. So we can simplify this as negative 3x squared over 1 minus x cubed. Next, let's have the function sine x, and the derivative of sine x is just cosine x. And just like the previous the previous rules, if we are asked to find the derivative of the sine of not just x but some other function in x, it would just be the cosine of f of x times whatever is the derivative of f of x. So if we have, for example, d dx, or the derivative of sine x minus x squared, and that will be cosine x minus x squared times the derivative of x minus x squared will be 1 minus 2x. We could just rewrite this as 1 minus 2x cosine x minus x squared. But let's say that you want to get the derivative of sine cubed x. Now for this, function, we will need a combination of this rule and the chain rule for powers, the one that said d dx of f of x to the power of n is equal to n f of x to the power of n minus 1 times f prime of x. And the reason for that is sine cubed x is actually sine x to the power of 3. So now this is your f of x and this is your n. So we could now use this. And using this result, we will then have 3 sine x squared, that's your n minus 1. And then f prime of x would simply be the derivative of sine x, which is cos x. So simplify this as 3 cos x sine x squared. And then this one, we just put that back to sine squared x. So 3 cos x sine squared x. The derivative of cosine x is similar, only that it is negative. So meaning d dx, or the derivative of cosine x, is equal to negative sine x. And similar to the previous one on sine, the derivative of cosine f of x is negative sine f of x times f prime of x. So let's take this example. Let's get the derivative of cosine 1 minus x squared. So it will then be negative sine 1 minus x squared times the derivative of 1 minus x squared, which is negative 2x. And then just simplify this as positive 2x sine 1 minus x squared. But if we have d dx of cosine, say, cosine to the 5th of x, again, we need a combination of this rule and the power rule, the chain rule for powers, which is f of x n equals n f of x n minus 1 times f prime of x. So let's rewrite this first as d dx of cosine x to the power of 5. They are equivalent. So this is now our f of x here. So if we do this, we will have 5 cosine x to the 4th times f prime of x will be the derivative of cosine x, which is negative sine x. Then just simplify this as negative 5 sine x cos x to the 4th. But cos x to the 4th, just rewrite cos x to the 4th as cos 4th x. Next one is tangent. So the derivative of tangent x is 1 over cosine squared x. So the derivative of tangent f of x will be 1 over cosine f of x, actually cosine squared f of x times f prime of x. So let's take an example. And let's take the derivative of tangent x squared plus 2x. So Using this formula, that will just be 1 over cosine squared x squared plus 2x times the derivative of x squared plus 2x, which is 2x plus 2. So we can just simplify this as 2x plus 2 over cos squared x squared plus 2x. And suppose we have d dx of 10 squared x. Like the previous ones, we are going to use this, a combination of this and the chain rule shortcut form, the chain rule for powers. So f of x to the power of n equals n f of x n minus 1 times f prime of x. So let's rewrite this as d dx of 10x squared. So this is now our f of x to the power of n. So the derivative would be, to do this, it will be 2 10x to the power of 1. And then this will just be the derivative of tangent x, which is 1 over cos squared x. So if we simplify this, this will just be 2 tan x over cos squared x.